Good afternoon, everyone. Um, my name is Dustin, and we're going to look over this weather event that is occurring over here in Nebraska. As we can see, we got a huge, narrow, enhanced risk through this region of Minnesota, North Dakota, South Dakota, Nebraska. It seems like this region's been very active for the last couple days. Um, Earlier, we had a couple tornado warnings. Let's see if I can loop this. So as we see, we did have some tornado warnings that did happen, but as soon as they were up, they were down. So now we're going to do a quick brief analysis of what is happening through this region and why those tornadoes warning was issued. Earlier, they had a mesoscale discussion over this region. A localized corridor for tornado potential exists in central Nebraska where surface winds have backed. So we can see the backing of these winds. This definitely helps with feeding the inflow into these storms. Now with these winds being backed, it could cause the storm, according to when I read it earlier, caused the storm motion to move away from the cold pool, which could decrease the chance of tornadoes through the evening. I don't have any clear indication of that right now. First, we're going to look at the balloon data. This is at 00Z, so this is about an hour ago. These storms are happening down here. In Nebraska. As we can see there is some low-level winds. We can see the backing. Right here, we can see the cape. About mixed layer 1885. Very little convective inhibition. We can see our effective shear is about 60, so it's on the low end. Our SRH is about 140, 0.1 kilometers, so that's not the highest. Our surface 3 kilometer is 392, which is moderate. Effective inflow 350, which is up there. One thing that really takes away is our surface 1 kilometer. Usually you want these 1 kilometers to be higher, but it definitely doesn't take away the risk of a brief spin up tornado. As we can see, our lapse rates are fairly steep. This is not exactly where those storms are, but it gives us a general idea of what is happening. Okay. Now, we'll look at these storms. So here's our storms. First things first, let's look at our 850 millibars. As we can see, the 850 millibars, these are the lowest winds, aren't very strong, but you can see them backed. You can see where they turn right here, they're backing. Usually, when they back, it's probably because of a low or something, but let's go confirm this. Let's look at our weather prediction page and see what our latest fronts look like, or what was the latest. So these storms are in Nebraska. So as we can see, there's a cold front coming through. So these storms are riding along a cold front through here, and we can see that there is a low, but it's farther south Nebraska. But you can see that these winds down here did turn toward it. Let's see what happened an hour ago. So these winds were more southerly, and then we can see the winds faintly turn through this region right here, through this region right here. Okay. So now, next thing, I bet you our upper level winds are just fine. We'll look at the 500. So we got plenty of upper level winds up here. Now we'll see how much of it's effective. So it's pretty effective to here, but if we look at our surface 1 kilometers, I bet you it won't be as strong because there's not as much low level winds through this region. So as we can see, there's very little. So about 10 knots through this region, barely speaking. And usually you want your lower levels to be a little higher. So now we're going to look at our surface 1 kilometers. As we can see, only a 50 to 100 as we saw. So only 100 through that region. So not very much SRH from the surface 1 kilometer. But if we look at our surface 3 kilometer, we can see a little bit more. Now, if we look at our extremely surface to 500 meters, this is not to 1 kilometer. There's very little of it in this region. As we can see, about a 50 through this for this lower storm, some 50 pockets. So there is a little bit, but not much. So I can probably see not maybe very brief tornado could happen with this. So if we look at the new significant tornado parameter using the surface, so just a 1, so it's very limited, 0.5, 0.25, so not very high. Not very high. Now if we look at our EHI is a little bit high, is a 1 with a pocket of a 3 and a 2 here and there. So we do have a little bit of energy helicity, but like I said, the low levels are not very favorable for a strong tornado. Might have a brief spin up. Now if we look at our mixed layer cape, so we can see these storms have formed out in this pocket of very little to non-convective inhibition through this region. So these storms aren't having to deal with a lot of convective inhibition, which would definitely help with that brief chance of tornadoes, even though it's not really high. So now if we look at our supercell composite, it's a 20, but like I said, this doesn't take in consideration the very low levels. So our chances are for tornadoes is very low. As of right now. This is our bulk Richardson number, in case anybody's wondering what that is. I'll show y'all. Bulk Richard. Here we go. Bulk Richardson number. So here's a general idea. Bulk Richardson number is a ratio of buoyancy of vertical shear. BRN, mixed layer cape. U is the wind speed differential between the density weighted 0 to 6 kilometer mean winds and the lowest 500 meter winds. The BRN is meant to estimate the balance between vertical shear and buoyancy, so it's taken in consideration both vertical shear and buoyancy. The low BRN values suggest that vertical shear that is too strong relative to the buoyancy, and larger BRN values are suggested of multi-cell clusters. So let's have a look. So as we can see, we got fairly low numbers, about a 20. So keep that in mind. We're going to count that as a 20. Intermediate BRN values favor sustainable supercells. BRN values in the range of 10 to 45 have associated with supercell by numerical. So anything between 10 to 45. Close proximity sound reveals that supercell environments with larger CAPE and larger results in BRN values. So larger CAPE equals more BRN in the range of 50 to 100 than suggested the original model. So we're looking for anything between 10 to 45. Maybe. I'm still learning this. This is a new thing I've been looking up or learning. Less than 45. Bulk research numbers less than 45 support supercell convection, while values greater than 45 support multicell or ordinary convection. So this makes sense. Where less than 45, we're at 20. So supercell convection. That's pretty much what's happening here. So about 20 through here. But like I said, these low level shears is not the greatest. We got some modest lapse rate, so there's still a chance of hail here and there. But as I believe as the nighttime falls, this whole system will eventually weaken. We'll see what the low level shear does for Curiosity, or what the wrap does for the low level shear. So as we can see, it completely diminishes as the storms continue north. We'll see what our surface 1 kilometer helicity does. Oh wow. This must have just updated. Okay, so we got plenty of 0-1 kilometer SRH. Okay, let's check out the 0 to 500 meters then. Oh wow, this must just have updated. Well shoot, now we got plenty. Okay, very interesting. But as we can see now, there's convective inhibition, probably because of the cold pools of these storms being really strong. See, now these storms have convective inhibition. They gotta work through. Let's refresh this and see what's happening. So they just took off that tornado warning. Okay. So as of right now, we got no tornado warnings. Oh, wait. Let me take that back. Yeah. No tornado warnings as of right now. So. Storm development is likely to increase over the next couple hours. Okay. So the low level jet this evening tonight will likely increase storm coverage across this area. storms will be elevated. So what we probably need to look at here is see what our LCL heights are looking like. Right now they're relatively low. Let's see what our LSC heights look like. They're low. Okay. Let's see what happened a few minutes ago. As we can see, the higher numbers are back here with these new storms firing up about 1,500 meters above ground level from the ground up. Okay. See how our energy helicity has changed. So we got a lot of energy helicity from 1 kilometer since this update. There's some convective inhibition. These storms are relatively low. See what our dew points look like. $68. Okay. These storms have to go through max convective temperature of 90. And it's what temperature right now? 66. 84. Okay. Okay. Oh, you got radar sight in the middle of all that. Okay. See what's happening. Hello. So you got 1, 2. This one looks more linear. It looks like a new development down here. So let's see. Settings. Oh, link copy. Here we go. Every 2 minutes. Yep. Okay. And it looks like we got another small development down here. So it's like we got 1, 2, 3, 4 in a row right here. That's interesting. Now we got plenty of zero, but we can't overcome the convective inhibition is the question now. So that's 1, 2, 3, 4. So we're coming from those storms. It'll be interesting to watch. I wonder if it's because of that cold front. These storms are going to start interacting because somewhere around in here is the cold front. Usually you can tell by the helicity. So our cold front's about right in here. Let's click this and see what's going on. Discrete slash. So as we can see, LCL heights are almost too high. They're at 1,623. Our effective helicity right there is only 136. Well, our cape is fine. Check down here. So our LCL heights are lower down here. See the box of whiskers. So this is in a pretty decent spot with plenty of effective helicity. Okay. Let's check this storm. I bet you there'd be more convective inhibition probably, but so our LCL heights are a little high. And our dew points are, I don't think it's quite as high up here. So I think these storms down here, down the line, has a better chance probably. Definitely this back end storm, as long as nothing impedes it. But I could be wrong. It does have to overcome convective inhibition. So my next storm of watch is this bottom. I think it's this one right here. Let's watch that storm right there. I think I already got pulled up. Okay. But as we can see on radar, we can see it probably becoming linear. But it's the right mover. Our storms are wanting to go east, but we can see way how these tops are. The winds are going this way, the storms are going east, and you can see. So we can probably imagine our vortices like this, and they're working into the storm maybe. Oh, they got another mesoscale. Okay. Several storms persist from central through north central Nebraska along the and north of the stall front. Oh, there's a stall front right here. That might also explain why there's an increase of helicity through this region. The southern low-level jet has increased to 4 knots based on the latest VWP, and this feature has photogenic forcing, vertical wind profiles with 40 to 50 effective bulk shear within the moderately unstable environment will continue to support more supercell structure. But there will also be a tendency for some storms to evolve into clusters as they spread northward. Primary threat remains large hail and damaging winds. The window of opportunity for isolated tornado or two should gradually decrease, given storms are developing in a post-frontal regime where the near surface layer is stabilizing. Yep, that means that cold pool starting to strengthen. I wonder why it doesn't show that little stationary front right there. Or is this just now updating? When did it update? 0Z? Explains why there's a lot of helicity though. I wonder if we can see that with the let's see. Meteor weather. Let's see if we can find that little stationary spot. Okay, so we can see the winds. So we can see 79, 83, 87. We can see these winds that are back. Let's have sunlight. No, I think it'd be too dark now. Let's go radar. Okay, so here's our storms. Oops, didn't mean to go out that far. Okay, so here's our winds coming from the south. Southeast. That's interesting, these. So I guess our front's like right in here. You can see because these winds are coming this way, and you got winds coming down this way, and they're like right here. That's very interesting. You can see it right there. Our winds from on ground are heading this way. From north. Very interesting. Let's see if I overlook something. Okay, we got a severe thunderstorm warning. Okay. Let's see if I missed something. Let's go to 925. These are the lowest winds. Okay, so you can see these winds coming from. See temperature, dew point, wind knots. So you do have winds coming from the south right here. You got these winds coming this way. Okay. Now stationary front's like right in here. You can actually see that right here. See how these heights spike like that? Usually when they spike like that indicates some sort of low or front. So definitely right in here. So they were saying about our winds are increasing. So let's see what's happening with our 850. Uh-oh, it may be updating. I don't know what it's doing. It's doing its own thing. Oh yeah, right here, Genesis. Right. So if these storms are going to do it, we're going to have to go do anything. Oh wow, that storm just totally disintegrated. Right there. Wonder if that means our bulk Richardson number went up. Still learning about it. Hmm. 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 I don't know. Values in the range of 10 to 50 suggest environmental favorable for supercell development. And again, this is Wikipedia, so. Ah, here we go. 45 Cape much higher than the shear. Often pulse. Cape is weaker to moderate. Aha. Shear much higher than Cape. Okay, so we're going to use the standard. Okay, let's see. Let's refresh. Let's find our bulk Richardson number. Okay, so we are looking at a 15 to a 20. Okay. Ooh, where did it go? Where's my page? We'll just click on every single. Okay, here we go. 15 to a 20. Hmm. Well, this is what I think it's suggesting. The shear in this environment is almost too strong for the cape. Because 12 is greater than 10, but it's less than 45. Cape determines updraft strength, while shear determines storm character. Let's see. Multi-cell storms are favorable in case where good speed shear is presented by Low-level directional shear is weak. Okay, that's kind of what's happening. Pulse storms are favorable in case of high CAPE and low shear. Supercells are favorable when CAPE and shears are in balance, and both are significant. Okay. To me, it looks like something absolutely just destroyed this storm right here. Me. And again, we got a lot stronger upper level winds, so we do have lower level winds. Not saying that's the fact, something that could have caused it, because I'm not a scientist, or I just like to study. I mean, I try to learn as much as I can. That'd be interesting to look up. Deep moisture convergence. So we got a lot of convergence. Probably I expect more storms to form out here in a little while. So surface 1 kilometer shear has increased through this area. Very interesting. But it has to overcome some convective inhibition now because the cold pool of these storms. Severe thunderstorm warning for South Dakota. And these storms are looking very linear. Mm-hmm. How linear and windy this event's looking. Crazy how high these numbers are. But those are just numbers. Makes you wonder what they're seeing and we're not seeing, right? I mean, models are like, hey, huge chance of tornadoes, and storms are like, no, can't do that, sorry. Oh, so just, okay. Vorticity generation parameter is meant to estimate the rate of tilting stretching of horizontal vorticity. Hi, let's look at this. I didn't even know this was here. Oh my gosh, what do all these numbers mean? Probably should have read them. Okay. Values greater than 0.2 suggest an increase in possibility of tornadic storms. Okay. What numbers do we have? So we got a 0.3. It's kind of weird. The only limiting factor here is there's a little bit of convective inhibition. And these storms are like, whatever. Oh man, the malls are screaming, oh, there's gonna be tornadoes. And the malls and the actual storms are like, whatever. If you say so. That's why you gotta love Mother Nature. She gonna do what she gonna do. Oh wow, that developed a new hull core. Makes you wonder if it's trying to regenerate or something. Refresh! Or is it refreshing? I don't know. Why are we not looping? Loop. That storm looks impressive. Just on radar though. So what it says on velocity. I'm gonna say it looks like it's trying to come around, but not sure. This is very interesting to watch. Very interesting to watch, for sure. So far they only got a severe thunderstorm warning on it. I might need to exit some of these tabs. Sounds like a good deal. Refresh. I don't think we need that anymore. Probably need to refresh this. Okay. Definitely watching these storms down here. Oh, this looks more right. You can see like a little inflow notch of some sort. So it looks like it's trying. Maybe. Something to watch. So I go overcome some of that convection. So as we can see, there's not very much on this velocity. But you can see it's trying right there. Interesting. See if it can do it. Surface vorticity. I say it's coexisting pretty good. I'm learning a lot from this event. All about learning. Almost every setup I ever watch, I learn something from it. I mean, you can see it's trying. Will it? It's a question of will it become linear again? Very good questions. I mean, you can see it's redeveloping. It's got a nice hell core, so you can definitely tell there's nice updraft forming within that storm. So, what's been? We shall find out soon. Oh no, battery running low. Will the storm do it? I have no idea. Say it looks nice on radar though. I can give it that. And the mesoanalysis says yes, there is a chance. But like I said, there's convective inhibition. And let's see, is this storm? This looks a little outdated. But I think it's one of them stores, so we're gonna click in between. Ooh, our LCL heights are kind of high though. It'll be interesting. Oh, we got a tornado with that storm. Look at there. It did it. Please take your shelter if you live in Sioux Falls, South Dakota. Wait a minute. That's the radar site. My bad. My apologies. So yes, you can definitely tell. I wonder if that's the storm. That's the reason why I hate this website, because it takes them so long. But that does look really nice. I mean, just looking at that right there. Where is this tornado warning at? Why haven't y'all updated? Okay, here it is. Oh no, it might be our northern storm. It may not be the southern storm. Why is this not updating? Oh, technology, gotta love it. Come on. Show the tornado warning. I think it's that one. Even though neither one is still showing it. Come on. This one's becoming more of a right mover, maybe. Oh, maybe not. I don't know. I love how NextLab got this faster than their own website. This is sad. Oh my gosh, are you kidding me? Oh well. So, general rule of thumb, if you're in the polygon, please take shelter, get away from windows and stuff like that. Get to the center of your house. Yep. I generally think, why? This is crazy. This is madness. I mean, why? Okay, so it's near. So it's that southern. Okay, so it's near south of south. east of Lake Andes. So if you're anywhere in this small polygon, please take shelter. Get away from all windows. Please don't step outside and try to look at it. Probably not the best idea. I know everyone's very fascinated on, oh, hey, tornado warning, let's go outside and look. Like I said, that's the best idea. And it's still funny how I haven't got a tornado warning yet. Like, how can this be like, oh, hey, there's a tornado warning, and the other one's like, no, what is happening? Get your stuff together, people. Put that polygon on. Wait, it's taking this website so long to put that polygon. By the time it's done, are you kidding me? Sorry, totally not raging. Oh, they added it, and they took it off. Well, that was brief. Now what happened on this side? Oh, they canceled it. Oh wow. What? As fast as they put it up, they put it down? What is happening? Well, let's look. We know what radar sites to go look at. Let's see what just happened. So it'll be that radar site. It'd be with this storm down here. Huh. I'll say that's a pretty nice couplet. But, huh. Base velocity? Show us any different? Wow, that does look really good. You know, it's starting to look a little linear, but as fast as it's there, they cancel it? Are you kidding? But yet it's on this website. Maybe I need to refresh. Refresh! Nope, it still says it's there. Even on their local radar, it shows it. Huh. I have no idea no more. People, we got issues. Oh, so it's still there. There we go. I'll exit off this other website. Where'd it go? That's the one that did that. There we go. And I said that looks like a very nice couplet for them just to cancel it. And you can see it right there clearly. I'm at this other one. Right there. Even this northern one, but it looks more. Because you guys can see the. Oh wow. Looks like a donut hole right there. Let's see what's happening with our correlation coefficient. Let's see if we got a brief confirmed tornado on the ground. Don't see much. Equitops. Wow, it boom. So you can see still a nice little couplet. I mean, look at that hell core right there, boy. Alright, that's very nice. And you can actually see it rotating into the storm. That's crazy. Okay, so far that's the only thing. That was the storm I was not expecting to go tornado warn. I thought the LCL heights are too high, but then again, that's why we learn. But when you look at this, our surface vorticity and mixed layer cape is really high right here. So that makes sense, according to the thing I read. I'll show you what I was looking at. See the this one, surface vorticity. It says the lowest 3 kilometer ground levels, the surface relative vorticity. Areas with a large 0 to 3 cape tend to favor strong low level stretching, can support tornadic ground. I think this is mixed layer cape, and this is surface vorticity. If we look at our 0 500, oh, but here's the interesting thing. As we can see, I don't know, like I said, sometimes these lines can be a little sus, but you can see it's close to the 100. Very interesting. And then, if we look at this, anything above 0.2. So we're looking for anything above 0.2. As we can see, what's this line? You gotta find that number. 0.3. So this number is relatively high. Okay. And in case y'all don't know what this is, vorticity generation parameters. So it's starting to make sense. And our energy helicity index is fine right there. And our shears are fine. Our helicity is meh, but it's still there. Storm is still feeding that vorticity in according to, see if I can find it again. I gotta find it again. Aha. Now, let's figure out something, shall we? Let's figure out how we read this. Okay. Oh no. Okay, yeah, that doesn't help. Okay, let's see. Surface, how to read. Let's see if I got this right. How to read SR surface vorticity and MLK. Oh, what's MLK? ML 0 kilometers. 0 through 3 kilometers. Here we go. Wait, we might be looking at the wrong thing. Even though this is useful, if y'all can find this website, please look over it. This gives you all the box and whiskers in the world. And it's very nice. Very nice. It definitely helps. Okay, let's see if I can find it. Okay, that's 0.6. This is effective bulk shear, severe hail. Bulk shear, 0.3 kilometers. Down drift cape. Hey, this is even better right here. If y'all can find this, this would definitely help. I'm definitely saving this website. Save. Wow. Well, I have no idea at this moment. Oh, here we go. Oh shoot, that's almost everything you gotta go over. Maybe if I do that. I don't know. I'll have to do more research on that. I just found that today. But notice they're overlapping. And that's what it said that you needed. Alright, back to the storm. Sorry, got distracted. So, uh-oh. Another tornado warning. Okay, but it looks like something's... Oh, man, that thing's got a donut hole. Oh, man. I bet you there's definitely a tornado warning, a tornado in that. But first, before we panic. Oh, there's some blue. Oh, man. Oh, let's refresh this. Refresh. Oh, man. That looks really nice. Do I dare say tornado? I don't know. But man, that velocity looks really good. Okay. So, we definitely got a situation in our hands. That is a given fact right now. Oh man, that upper storm. I was just wondering about this upper storm. How I was telling you about how the velocity was starting to look. I said linear, but I guess I was lying. My bad, y'all. I messed up. Oh man, you remember? See, it's overlapping here too. What is happening? This is crazy, y'all. I'm watching these lower storms because it looks better, but these two storms are up here just doing their thing. Learning something new. Yes, our helicity ain't that high. This is something. Learning. So, huh. Why are these two storms doing it, but my storm, not mine, but the storms I'm really watching are these two, and they're not. They're just having a hard time. Oh, man, I wonder if this the convective inhibition through that area is too strong. Could be that. Could be that. So, this has been a very interesting event, y'all. So far. Oh, got another one. Severe thunderstorm warning. See all the tornado warnings? That's all we had today so far. Refresh, maybe. Okay, there we go. Refresh. Oh man, it looks like it's quickly dying. Man. So what is making these two storms up here so special? Why? So this one down here is understandable. in a sense. What is causing this upper? See, there's no surface to 500. Be interesting to see if there's a tornado report with this storm. What is causing the storm? See, very little energy helicity index. If we look at this new thing, it's a 0.3. If we look at our mixed layer, only 2 let's use most unstable. Usually with nighttime, so these are kind of elevated. LCO heights are kind of higher. Let's see what's clicking near this area. Huh, everything hits the mark though. Let's do screen clusters. Oh wow. Effective helicity. Let's see if this is true. Effective helicity. About 300, yeah. Huh. Look at there. It's just our be interesting to see if we get a tornado report with the storm. So it almost hits everything you need. You have 0 probabilities. Really high. Let's go EF2. 10, 13, 11. Fairly. Yeah, 4. A 1. That's low, but still. A 1? Crazy. But as we can see, there's some convective inhibition. These storms just gotta work through, but I don't think this convective inhibition is really strong. So, nonetheless, we still got 2 current tornado warnings. Refresh. See what's going on with them. You can see that classic hook on this one. Let's go next to the next one. You can still see the velocity. If we go base. There we go. So it's not as well defined, but this bottom one seems to be strengthening a little bit. Man, look at that hook on that storm. You can see the upper level winds right here blowing the top of these storms. See, I'm going to show you that. For 500 winds, really strong through here. See the 700 winds going this way. You can see based on the cloud tops how they're shooting over this way. I was really thinking these storms right here would do it, but I was wrong. Oh well, we're all human. We'll make mistakes. I'll definitely try to predict better. See if we can confirm a tornado. Oh. Can't see anything offhand. Let's see, they got another severe thunderstorm warning. Okay. Maybe it's time to refresh this. Okay. It'll be interesting to see if they expand this. So if you're in the town of Mitchell, I surely hope there's not a tornado on the ground because it'll hit downtown Mitchell. Well, it may go a little. Well, it's going to hit pretty much downtown. I hope there's definitely not a tornado on the ground. Now, I don't see anything that's saying tornado. That storm. Luckily, it doesn't look as impressive as it did. So hopefully that's the sign of it weakening. Oh, tornado. So they probably expanded one of the. Oops. Let me see which one it was. Refresh. Crazy how Nextlab can catch on to this faster than. Probably for the southern storm right here. I certainly hope so. Let's see. Maybe I can refresh this. So far, nothing has changed. So what is Nextlab trying to tell me? Is it when they move the polygon just a little bit? Not sure. Also, this northern storm has a 0.5 chance of a tornado. I missed the little dash. That's using, but man, there is very little 0 to 500 meter SRH. In case y'all are wondering, this is a new thing that Vortex 2 has been working on. If y'all highlight this right here and look it up, it will show you, or here, search. This is the new thing that Vortex 2 has been working on it, and definitely if y'all interested in whether have the time to read this it shows a lot. It shows how the 0 to 500 meters has actually increased the chance of predicting tornadoes by, like, what did it say at the beginning? STP increased the number of correctly predicted by 8% and decreased the number of missed events and false alarms by 18%, as shown right here. So definitely recommend to look up this paper and kind of look over it like I have and try to learn a little bit about it. I still read this paper, still take notes and try to learn as much as I can from it. That's with any for real. But okay, so let's look at this. SARH values for 500 values meter per second. So let's look back right here. We're going to look at our box of whiskers. As we can see, everything is about in the 100 range. This is in the 50, this is the 25. So if we look at the box of whiskers, almost everything in the 50 range is almost non-tornado or weak, very weak tornado. Now where that 100 is at, there is a chance of a weak tornado according to this, but you gotta still consider in all the other factors like CAPE, convective inhibition, SRH, but this just gives you a general idea. So if y'all ever have a time, please, yeah, I definitely recommend reading some of this and look at the new STP parameters they have using the 0 to 500. So all they pretty much did is almost use the same formula, but they added the SRH to 500 with a 500 meter, which I found very fascinating. So they did expand both tornado warnings. I really hope there's not a tornado with that storm. With neither one, because this looks like if there's a tornado on the ground, there will definitely be a chance because it went through. It looked like it's going through downtown. Let's look at the velocity scans. As we can see, this one has dramatically weakened. This one's been maintaining its strength. So if you're still take y'all's precautions. Let's see. Refresh. So the storms I thought that was going to do something has absolutely done nothing. So I'm probably because of the convective inhibition. It looks like these storms are weakening. There we go. Well, I have a long, busy day ahead of me tomorrow, so I'll call it a night. Tell them, hope everyone has a good day. I might go back live tomorrow. I need to look what tomorrow SPC look like. Slight chance. I'll probably go live and we'll briefly go over what's gonna happen tomorrow. Until then, I hope everyone stays safe. And remember to keep your eyes on the sky.